Hello, class. This week we're going to take a look at Chapter 6 in our text, Test Selection, Scoring, and Statistics. Statistics play a crucial role in counseling when it comes to testing and assessments. Testing and assessments are important tools that we use, as we've been talking about, to help us better understand our clients' behaviors, emotions, thoughts, and address the issues, problems, and challenges that they bring to us. By using statistical methods, we can analyze the data gathered from our assessments and tests and use that to help us make informed decisions and provide effective treatment for our clients. One key aspect of statistics in counseling is reliability and validity. But reliability refers to the consistency and stability of a test or assessment over time. Validity, on the other hand, refers to the accuracy and relevance of a test or assessment in measuring what it is intended to measure. These two concepts are essential because they ensure that the data collected will be meaningful, can be trusted by us as we use it to make decisions and learn more and come to conclusions about our clients. And another important use of statistics in counseling is understanding the normative data. By comparing our clients' test scores to a norm group, we can determine how the client's scores stack up against the general population. This information can help us identify areas of strength and weakness. Statistics also play a role in identifying patterns and trends in our clients' behaviors and emotions. By using statistical analysis, such as correlation and regression, we can identify relationships between variables and perhaps predict future outcomes. Descriptive statistics play a crucial role in testing and assessments. These provide valuable information about the characteristics of a population, or a sample group, if you will, which can help inform decision-making and guide interventions. Descriptive statistics involve the analysis and interpretation of data to summarize and describe key features such as central tendency, variability, and distribution. One common use of descriptive statistics is to examine the scores on various assessments or tests administered to clients. For example, we may use descriptive statistics to calculate the mean, median, and mode of test scores to better understand the overall performance of a group of clients. This information can help us identify patterns and trends in client data. Another important aspect of descriptive statistics is the examination of variability in the test scores. Variability, again, refers to the extent to which the scores in a sample differ from each other. By calculating measures of variability, such as the range, variance, and standard deviation, we can better understand the spread of scores and the consistency of performance among clients. This information is crucial as it helps us determine the reliability and validity of assessments and tests that are used in our counseling. In addition to central tendency and variability, descriptive statistics also provide information about distribution of scores in a data set. So descriptive statistics is a branch of statistics that deals with summarizing and describing the characteristics of a data set. It helps to organize and present the data in a meaningful way, making it easier to interpret and understand. The two main types of descriptive statistics are quantitative and qualitative. Quantitative descriptive statistics involve numerical data that can be measured and compared. This type of data is typically continuous and can also be broken down into two types, discrete and continuous. Discrete data consists of integers or whole numbers, while continuous data can take on a value within a range. On the other hand, qualitative descriptive statistics involves numerical data that's categorized into groups or attributes. This type of data is often used to describe characteristics or attributes of a data set, which cannot be measured numerically. Qualitative data can also be used to describe the distribution of a data set, to compare groups within a data set. When analyzing data, it's important to consider both quantitative and qualitative descriptive statistics. By combining numerical and non-numerical data, we can paint a picture that's more complete of the patterns and trends within the data. As we talk about gathering information and understanding the needs of our clients, this is crucial as it helps us obviously come to an understanding of what the client's presenting issues and challenges are, and then working with them to talk about and identify goals for treatment. Best practice recommendations advocate that as we gather information through our comprehensive assessment, which includes the biopsychosocial, the MSE, and a complete history, it's also important to include assessments and tests as part of the gathering of data and information about our clients. Once we've determined what assessment or test is needed, we can then decide on the method that we're going to use. In previous chapters and lectures, we've talked about formal and informal assessments. Assessments and tests play a crucial role, as I've stated repeatedly, in helping us better understand our clients. There's a wide range of assessments and tests that are available, each tailored to meet specific needs. We talk about the mental health assessment that helps us evaluate a client's mental health status. Another type of assessment is a personality assessment, whereby we can gain insight into a client's unique personality traits, strengths, and weaknesses. Additionally, we may use assessments to evaluate perhaps our client's social functioning, perhaps their emotional functioning. These can help us identify any challenges or barriers or limitations that may be impacting a client's ability to function effectively. So it's important to have a good understanding of the wide range of available assessments in order to best meet the needs of our clients. It's important that we familiarize ourselves with all the various assessment tools. As we've talked about, it's in previous texts and chapters, it's important that we consider culturally appropriate and normed instruments for our clients. We need to carefully consider and select appropriate assessments or tests to ensure that they are relevant, reliable, and valid for the client's needs. One of the first steps in selecting an assessment or test is to consider the purpose of the evaluation. Is the goal to diagnose a specific condition? To measure progress? To gain insight into a client's strengths or weaknesses? Understanding the purpose helps us guide the selection process and ensure that the assessment aligns with the client's goals for counseling. Next, we need to consider the reliability and validity of the assessment. Again, reliability refers to the consistency of the results, while validity refers to the accuracy of the assessment in measuring what it claims to measure. So we need to make sure that we choose assessments that have been scientifically validated and are appropriate for our client's age, cultural background, and presenting concerns. We also need to consider the client's preferences and comfort level with different types of assessments. Some clients may prefer self-report questionnaires, while others may benefit from performance-based assessments or interviews. So we really need to make sure that we're taking into account our clients' preferences and their comfort level to ensure that they are engaged in the assessment process, because this can also perhaps skew the results. And another important consideration is the ethical use of assessments. We need to ensure that we have the appropriate training and expertise to administer and interpret assessments accurately. We need to consider the potential impact of the assessment results on the client and take necessary steps to provide support and guidance as needed. As I just talked about, the importance of selecting an instrument, an assessment, or test that, if you will, checks the boxes or the most boxes for what we're looking for in the assessment for our client, taking into consideration all the points that I just previously shared with you. So you can see that administering tests requires careful planning, adherence to standardized procedures in order to ensure their accuracy and fairness. We need to make sure that the administration of a test or an assessment is in a comfortable and non-threatening atmosphere. We need to be aware of any deviations or changes that are allowable and must occur to accommodate perhaps those who are living with a disability, perhaps aging clients, those that have difficulty reading and understanding based upon developmental stage, and also based upon primary language spoken, native language. So you can see that administering assessments or tests requires us to follow ethical guidelines and best practices. We need to ensure and also consider that the assessment or test may be impacted by cultural, linguistic, and developmental factors and make appropriate accommodations. Additionally, it's important to remember that informed consent must always be obtained before a client completes a test or assessment tool. There are various ways to score an assessment or test depending upon the scoring options, the instructions, the directions, the steps that are attributed to that assessment or test. This is oftentimes determined by the publisher's requirements. For example, there are tests that can be scored and are scored through computer-based processes. There are tests and assessments that are self-scored or hand-scored. Interpreting assessments is crucial and important, and that we do this in a way that holds true to the test or the assessment, what it is to be measured, what is measuring, and the guidelines for scoring and administering. Because we are gathering important information from our clients that we're using to help better meet their needs, provide a diagnosis, assist with diagnostic information, help develop treatment plans, etc. We also need to be importantly understanding of the limitations of the assessments themselves. They do provide valuable information, but they are not infallible. We need to consider the context in which an assessment or test is given, as well as any factors that may have influenced the results. We need to consider the client's unique background and their experiences. Different individuals may interpret questions differently based upon personal, social, or cultural experiences or norms. It's important that we be sensitive to these differences and consider them when we interpret results. Another important consideration when interpreting is the potential for bias. Assessments may inadvertently discriminate against a certain group of individuals, leading to inaccurate results. We need to be aware of these biases and take steps to minimize the impact on the interpretation of the assessment results. Again, it sounds redundant, but I want once again, reiterate that we need to consider the reliability and validity of the assessments. Additionally, we need to always make sure that we are interpreting assessment results in conjunction with other information gathered from our clients. Remember, these assessments and tests are just one piece of the puzzle. It's one piece of the larger comprehensive assessment of our clients. We need to consider the whole picture when developing a treatment plan for our clients. Norm reference tests are those where the performance of a sample population has been determined and serve to determine performance by comparing to others in that same population. Whereas interpreting test results through criterion referenced, these state and provide information on how someone does on a test relative to the predetermined performance level on a specified set of outcomes or criteria. It's essential that we understand the various scales of measurement that are used for collecting and analyzing score data. These scales provide us with valuable information about the characteristics of the variables being studied or being interpreted based upon the assessment or test. The four main scales of measurement are nominal, ordinal, interval, and ratio. The nominal scale is the simplest form of measurement. It's used to categorize data into distinct categories. Variables measured on a nominal scale do not have a natural order or ranking. Examples of variables that can be measured on a nominal scale are gender, ethnicity, demographic data. The ordinal scale is slightly more sophisticated. It does allow for the ranking of data in a specific order. Variables measured on an ordinal scale have a natural order, but the differences between the values are not consistent. Examples of variables measured on an ordinal scale might be income bracket, educational level. The ordinal scale provides more information than the nominal scale, making it useful for comparing and contrasting data. The interval scale is a more precise form of measurement that allows for the calculation of the difference between values. Variables measured on the interval scale have a fixed measurement unit and a meaningful 0 point. Examples of variables measured on an interval scale could be IQ, temperature, and often standardized tests. The ratio scale is the most advanced form of measurement and provides the most precise information about a variable. Variables measured on a ratio scale have a fixed measurement unit, a meaningful 0 point, and equal intervals between values. Examples of variables measured on a ratio scale would be height, weight, age. The ratio scale allows for the most in-depth analysis, often including calculations of ratios and proportions. Raw scores are one of the most fundamental calculations used in determining test scores. They serve as the basis for evaluating an individual's performance on a test in its simplest form. A raw score represents the total number of correct answers a test taker provides without any alterations or adjustments. While raw scores may seem straightforward, they are crucial as they can be used to assess a person's knowledge, skills, and abilities accurately. One of the primary advantages of raw scores is their simplicity, because they provide this clear, concise representation of the test taker's performance, thus making it easy to interpret and compare results across different individuals. Raw scores serve as the foundation for more complex statistical analyses, such as calculating percentiles, standard deviations, and z-scores. By starting with raw scores, we can delve deeper into understanding test performance and identify patterns and trends. Raw scores are essential for helping establish a baseline, thereby which we can measure growth and progress over time. Despite these importances, raw scores do have limitations. They do not account for factors such as question difficulty or test variability. Measures of central tendency are statistical tools that are used to analyze data and summarize the characteristics of the data set. The three main measurements of central tendency are the mean, median, and mode. These measures help us understand the center or average of a data set and provide valuable information about the data distribution. The mean, or average, is perhaps the most commonly used measure of central tendency. It is calculated by adding up all the values in a data set and then dividing by the total number of values. The mean is sensitive to extreme values, also known as outliers, and can be influenced by them. In other words, it could perhaps skew the result. The median is another measure of central tendency that's less affected by those outliers. It's the middle value in a data set, when the values are arranged in ascending or descending order. If the data set has an even number of values, the median is the average of the two middle values. The median provides a more robust measure of central tendency. The mode is the most frequent value in a data set. It is useful for categorical data or when dealing with discrete variables. In some cases, a data set may have more than one mode, making it bimodal or multimodal. The mode provides insights into the most common or prevalent value in the data set. These measures of central tendency are essential in various fields, not only within counseling, psychology, but also are found in sociology, economics, statistics, mathematics. Measures of variability are statistical tools that are used to describe the spread or dispersion of a data set. They provide valuable information about the distribution of data points and how closely they are clustered together. There are several commonly used measures of variability, including variance, range, interquartile range, and standard deviation. Variance is a measure of how spread out the values in a data set are around the mean. It is calculated by taking the average of the squared differences between each data point and the mean. A higher variance indicates that the data points are more spread out, while a lower variance suggests they are closer together. Range is the simplest measure of variability. It's calculated by subtracting the smallest value from the largest value in a data set. It gives an idea of how widely the values in the data set vary. Range can be sensitive to those outliers, as a single extreme value can greatly affect the overall range. Interquartile range is a robust measure of variability that's less sensitive to those outliers. It's calculated by subtracting the first quartile from the third quartile of the data set. IQR represents the range in which the middle 50% of the data points fall, thus providing a more accurate picture of the spread of the central values in the data set. Standard deviation is another commonly used measure of variability and indicates the average distance of data points from the mean. It is calculated by taking the square root of the variance. Standard deviation is a useful measure because it not only accounts for the spread of the data, but also takes into consideration the weight of each data point within the data set. Data distribution is a key concept in statistics. It helps us understand and describe the characteristics of a set of scores or data points. In simple terms, data distribution refers to how the values in a data set are spread out or distributed across different intervals. By examining the distribution of data, we can gain insights into the central tendency, variability, and shape of the dataset. There are different types of data distributions, each with its own unique characteristics. One common type of distribution is the normal distribution, also known as the bell curve. In a normal distribution, the data is symmetrically distributed around the mean, with the majority of values falling close to the center and fewer values at the extremes. The normal distribution is commonly used in statistics because it's easy to work with, and it provides key information about the data, such as the mean, median, and standard deviation. Another type of distribution is the skewed distribution. This is where the data is asymmetrically and skewed to one side. In a positively skewed distribution, the tail of the data points to the right, towards the higher values, while in a negatively skewed distribution, the tail points to the left, towards the lower values. Skewed distributions can affect the interpretation of the data, as it may be necessary to use different measures of central tendency and variability. Understanding the distribution of data is really important, as it aids in making informed decisions and drawing accurate conclusions. One way to visually represent the distribution of data is through a histograph. This is a graphical representation of the frequency of values in different intervals or bins. A histograph provides a clear visualization of how the data is spread out, and it can reveal patterns or trends that may not be apparent in just a simple table of numbers. When it comes to evaluating one's performance on standardized tests, score comparison with percentiles is a common method which is used to determine where a person stands compared to others who've taken the same test. Understanding how percentiles work and interpreting them correctly can provide valuable insight. Percentiles are a way of ranking test scores relative to a larger group of test takers. For example, if someone scores in the 80th percentile, it means that their score is higher than 80% of all the other test takers in that group. When comparing scores with percentiles, it's important to consider the distribution of scores for the specific test being taken. Some tests may have a broader distribution of scores, while others may have a narrower range. Understanding how percentiles work can also provide insight into areas for improvement. In addition to providing a benchmark, percentiles can also be used to evaluate effectiveness of interventions and programs. By comparing test scores with percentiles over time, we can track progress and identify areas where improvements can be made. Standard scores, also known as standardized scores or z-scores, are a way of comparing a person's performance on a test or assessment to a larger group of individuals. Standard scores provide a common scale for comparing individuals across different tests and assessments by converting the raw scores into a common metric. One of the main benefits of using standard scores is that they allow for easier comparisons between individuals by providing a measure of how far above or below the average an individual score falls. Standard scores are often used in educational settings. They are also used in psychological assessments to compare a person's abilities in various areas. To calculate a standard score, one must first determine the mean and the standard deviation. The mean represents the average score of the group, while the standard deviation is a measure of how spread out the scores are around the mean. With this information, one can then calculate a z-score, which indicates how many standard deviations an individual's score is from the mean. For example, if the mean score on a test is 50 and the standard deviation is 10, a score of 60 would have a z-score of 1, indicating that it is one standard deviation above the mean. Conversely, a score of 40 would have a z-score of -1. This indicates that it is one standard deviation below the mean. Standard scores have several advantages over raw scores, including the ability to compare scores from different tests or assessments, as well as the ability to easily interpret performance relative to a larger group. Standard scores also allow for the comparison of scores across different populations, as they provide a common metric for assessing performance. Standard scores are common ways to measure and compare different types of data. These scores are used to provide a standardized way to assess an individual's performance. Some common types of standard scores include z-scores, which I just referenced in the previous slide, t-scores, Stanines, Sten scores, and deviation IQs. Z-scores are one of the most commonly used type of standard score. Again, a z-score measures how many standard deviations a data point is from the mean of the data. T-scores are similar to z-scores, but are often used in situations where the mean and the standard deviation of the data set are not known. Stanines are another type of standard score that divides a data set into 9 equal-sized groups, with Stanine 1 representing the lowest, 4.5% of scores, and Stanine 9 representing the highest, 4.5% of scores. This measurement is often used on performances that can help identify areas of strength and weakness. Sten scores are a variation of Stanines that divide a data set into 10 equal-sized groups, again ranging from 1 to 10. Sten scores are commonly used in psychological assessments and are particularly useful for comparing an individual's performance on different tests. Deviation IQs are a type of standard score that measures an individual's intelligence relative to a standardized population. A deviation IQ of 100 is considered average, with scores above 100 indicating above average intelligence, and scores below 100 indicating below average intelligence. Normal curve equivalent, often abbreviated as NCE, is a method used to compare scores from different tests or assessments on a common scale. The purpose of NCE is to provide a way to standardize scores so that they can be easily compared and interpreted across different measurement instruments. The normal curve equivalent is based on the normal distribution, also known as the bell curve. In a normal distribution, most of the scores cluster around the mean, with fewer scores at the extremes. By converting the raw scores into NCE scores, we can see where a particular score falls within the overall distribution of scores. NCE scores are especially useful when comparing performance on standardized tests. To calculate the NCE score, we first need to determine the percentile rank of the raw score. The percentile rank indicates the percentage of scores that fall below a particular score. Once we have the percentile rank, we can use a conversion table to find the corresponding NCE score. One of the key advantages of using NCE scores is that they are easy to interpret. Additionally, NCE scores are useful for comparing performance across different tests that may have different score scales. So by converting the scores into NCE scores, we can standardize the scores and make meaningful comparisons. Norming sample is a crucial aspect that involves developing norms or standards for a particular population. It is essential to have an adequate representation of the target population to ensure the validity and reliability of the findings or the results. When conducting norming sample, typically we select a sample that represents the characteristics of the population that is being studied or being tested. The sample needs to be diverse relative demographics, providing a comprehensive understanding of that said population. Once the sample has been selected, the tests or assessments are administered to gather the data on the variables of interest. This data is then analyzed to determine the norms or standards. The norms serve as that reference point for comparing scores and determining if they fall within the expected range. In addition to establishing norms, norming sample helps identify potential biases or limitations. One of the key challenges in norming sample is ensuring that the sample is representative of the population. Age and grade equivalent norms are often used as benchmarks. These assess oftentimes academic achievement or development. These norms provide a standard against which an individual's progress can be compared. Age equivalent norms are based upon the person's chronological age, meaning the number of years since birth. Grade equivalent norms are based on the person's grade level in school. While age and grade equivalent norms can be useful tools, it's important to understand their limitations. These norms do not take into account individual differences within developmental and learning styles. Additionally, age and grade equivalent norms can be influenced by a variety of factors. These include cultural background, socioeconomic status, just to name a few. Measures of relationship or correlation between variables, constructs, or scores are essential tools in data analysis. These measures help us understand the extent to which two or more variables are related or associated with each other. By examining relationships between variables, we can identify patterns, trends, and dependencies that can inform decision-making. One commonly used measure of relationship is correlation. Correlation measures the strength and direction of the relationship between two variables. The Pearson correlation coefficient, for example, quantifies the linear relationship between two continuous variables. A correlation coefficient close to +1 indicates a strong positive relationship, while a coefficient close to -1 indicates a strong negative relationship. A correlation coefficient of 0 suggests no relationship between the variables. Correlation coefficient is a statistical measure, again, that quantifies that relationship between the two variables. As I just referenced in the previous slide, if it ranges from -1 to 1, where -1 indicates a perfect negative correlation, 0 indicates no correlation, and 1 indicates a perfect positive correlation. One important aspect of correlation coefficient is that it does not imply causation. Just because two variables are correlated does not mean that one causes the other. It simply indicates that there is a relationship between the two variables that may be worth further exploring. The calculation of correlation coefficient involves several steps. First, you need to calculate the mean of each variable. Next, you calculate the covariance between the two variables, which measures how they vary together. Then finally, you divide the covariance by the product of the standard deviations of the two variables to get the correlation coefficient. The most common types of correlation coefficients are Pearson correlation coefficient, Spearman's rank correlation coefficient, and Kendall's tau coefficient. Pearson correlation coefficient, also known as Pearson's R, is the most widely used correlation coefficient. It measures the strength and direction of the linear relationship between two continuous variables. Spearman's rank correlation coefficient is used when the variables are not normally distributed or when the relationship between them is not linear. Instead of measuring the relationship between the actual values of the variables, Spearman's rank correlation coefficient measures the relationship between the ranks of the variables. Kendall's tau coefficient is a non-parametric correlation coefficient that measures the strength and direction of the ordinal relationship between two variables. It is similar to Spearman's rank correlation coefficient, but takes into account tied ranks, making it more robust to ties in the data. In addition to these common types, there are several other specialized correlation coefficients that are used for specific types of data. For example, the pi coefficient is used to measure the association between two dichotomous variables, while the point biserial correlation coefficient is used to measure the association between a continuous variable and a dichotomous variable. Regression analysis is a statistical technique that's used to study the relationship between two or more variables. It's primarily used to predict the value of one variable based on the value of another variable. Regression analysis is a popular tool in various fields, psychology and social sciences, as well as finance and economics. It helps in understanding the nature of the relationship between different variables. The basic idea behind regression analysis is to find the best fitting line or curve that can describe the relationship between the variables. The line or curve is known as the regression line or regression curve, and it's used to predict the value of the dependent variable based on the value of the independent variable. The independent variable is the one that is used to predict the dependent variable, while the dependent variable is the one that is being predicted. There are different types of regression analysis, such as simple linear regression, multiple linear regression, and logistic regression. In simple linear regression, there's only one independent variable, while in multiple linear regression, there are two or more independent variables. Logistic regression is used when the dependent variable is binary or categorical in nature. The regression line or curve is determined by minimizing the sum of the square differences between the observed values of the dependent variable and the values predicted by the regression line or the curve. This is known as the least square method. It helps in finding the line or curve that best fits the data. Regression analysis helps in assessing the significance of the relationship between the variables. This is done by testing the null hypothesis that there is no relationship between the variables against the alternative hypothesis that there is a relationship between the variables. The significance of the relationship is determined using statistical tests, such as the t-test or f-test. Regression analysis is a powerful tool. As I mentioned, it's widely used in the social sciences, economics, and finance. However, like any statistical technique, regression analysis is not without its limitations. One of the key limitations of regression models is the presence of errors. Errors in regression models refer to the discrepancy between the observed values and the values predicted by the model. These errors can arise from a variety of sources, including measurement error, omitted variables, and model misspecification. Understanding and addressing these errors is crucial for ensuring the reliability and validity of regression results. Measurement error is a common source of error in regression models. It occurs when there are inaccuracies in the measurement of the variables, leading to biased estimates of the regression coefficients. Omitted variables are another source of error in regression models. Omitted variables refer to variables that are not included in the regression model, but are related to both the independent and dependent variables. Failure to account for these variables can lead to biased and inconsistent estimates of the regression coefficients. Model misspecification is another source of error in regression models. It occurs when the functional form of the regression model is incorrect, or when important relationships between variables are not accurately captured. This can lead to biased estimates of the regression coefficients and inaccurate predictions. Selecting, administering, and scoring assessments are crucial components of testing and assessment in counseling. These processes ensure that accurate and reliable information is gathered to support our clients and help us make informed decisions. When selecting assessments, we must consider the purpose of the assessment, the population being assessed, and the psychometric properties of the instrument. It's essential to choose assessments that are reliable, valid, and culturally sensitive to ensure that accurate information is obtained from our clients. Assessments should be chosen based on the client's presenting concerns and the goals of counseling to ensure that the information gathered is relevant and meaningful. Administering assessments involves following standardized procedures to ensure that the assessment is administered in a consistent and reliable manner. It's important for us to be trained in the administration of assessments to ensure that clients' responses are accurately recorded and interpreted. As stated earlier, we must consider factors such as our client's level of understanding, language proficiency, and cultural background when administering assessments to ensure that the assessment is administered in a way that is respectful and inclusive. Scoring assessments involves interpreting our clients' responses to determine the results of the assessment. We must follow the scoring procedures of the assessment to ensure that the results are accurate and reliable. Scoring assessments involves comparing our clients' results to normative data to determine how our clients' scores compare to others within the population, and to identify the areas of strength or areas of concern to which what is being measured through that assessment tool.